The next problem that we are going to deal with is I'm a good student, excellent student, whatever. Teacher Snell is teaching at an excellent high school because there are a lot of excellent students in his school. So in this school, to determine if a student is excellent is very easy and simple. In this school, every student has an ID. If a student's ID is not visible by any other student ID, then this student is an excellent student. This is a ridiculous way. But, this is only a made up situation for this problem, alright? Don't be too serious about this. Okay? Now you are given a student ID. Please try to find out if this student is excellent, alright? Okay, the input has got only one line with only one integer and ID, and the ID is between 2 and 10,000, alright? Why does the ID start with 2? Why doesn't the student ID start with 1? Usually when we try to number something, we always start with 1 instead of 2. Why does the ID start with 2 in this problem? Does anyone have any clue about this? If the student ID start with 1, what's going to happen? This student with the ID of 1 will be able to divide any other student ID. That means he will be the only excellent student. And all the other students' ID will be divisible by 1. And no one else is excellent. And that contradicts the first statement of this problem. It states there are a lot of the excellent students at this school, alright? But if we start with 1, and then the ID 1 will be the only excellent student, because it can divide all the other student IDs. Do you know why? Do you understand what I'm talking about?
Maybe.
Actually, this problem is trying to determine if ID is a prime number. What is a prime number? What is a prime number? A prime number is an integer. Cannot be divisible by any other positive integer. except for 1 and itself. That is a prime number. Does anybody know what it means in Chinese? A prime number.
I don't know.
You know? Like 50, like 91. 91 is not a prime number because except for 1 and 91, 91 can also be divided by 7 and 13. So 91 is not a prime number. While 90, while maybe 89 is a prime number because 89 can only be divided by 1 and 89, not any other integer. And the series of prime numbers start with 2 is actually 2, 3, 5, 7, 11, 13, 17, 19, 17, 19, 23, 29, ... So do you know what a prime number is now? I don't want to say that in Chinese. I'm trying my best to let you know what a prime number is in English. And you have to be able to understand what a prime number is in English. Does anybody has any idea what I'm talking about? Oh, I'm sorry. I didn't check the message board. Yep, there are 4 students. 怡童志远, 对, Junbo were they all provided the correct answer. Yes, this is the prime number, right? So this problem is actually trying to asking you to determine if an integer is a prime number, alright? For this problem, unfortunately, doesn't really have a very effective way of solving it, like the problem of greatest common denominator, GCD, has got a very efficient way of Euclidean algorithm. But to determine if a integer is a prime number or not, there isn't a very, very efficient way of doing this. So we'll do the enumeration. We'll try the enumeration, alright? Okay. That's how we do it. ID is equal to int I'm sorry, int input, and then the denominator. You already know what a denominator is. Let's greatest the common denominator. What is a denominator? Denominator means a number that's trying to divide another number. All right, that's a denominator. And then we try the denominator starting from 2, not 1, from 2. And then while ID is not divisible by D, the first D is actually 2. When it's not divisible by D, then we'll increase D by 1. That means if ID is not divisible by 2, then we'll try 3. Then if the ID is not divisible by 3, we'll try 4. If the ID is not divisible by 4, then we'll try 5, etc. Until one day the ID is divisible by D, then it will exit this loop and jump to the next statement that follows while statement. But now, after we find the first D that would divide ID evenly, then how do we determine if ID is a prime number? How do we find out if ID is a prime number? How? That the first two, okay. Let me rearrange this. Okay, 91. For 91, there are 4 denominators, alright, which are 1, 7, 13, and 91. And 89 has got 2 denominators, 1 and 89. However, we don't want to see 1. We don't want to look at 1. We start the denominator of D start with 2. Alright? So 1 is out of the problem. We'll start the next one. So D will be the next, starting with 2 and the smallest denominator of ID. And for 91, the first denominator is 7. For 89, the first denominator except for 1 is 89. Do you see the difference? If D is 7, which is not equal to 91, and 91 is not a prime number, alright? And if the first denominator is 89, there isn't any other integer between 1 and 89 can divide 89. That means 89 is a prime number. So you just have to decide to check if the D is equal to ID. If it's not equal to ID, then it's not a prime number. And if it's equal to ID, then it is a prime number. So we'll try to tell if D is equal to ID, then will print no. When it's equal, it's yes. Yes, it is a excellent student. Alright? And else print no. And this is the answer to this problem. And like I said, this is not a very efficient way because we try every number starting from 2. We try 2, we try 3, we try 4, and if ID is a very big number and if ID is a prime number, then we will increase D all the way to ID. One by one, then we will until D is equal to ID, then we will know it's a prime number. It will take a long time. However, for this problem, ID is not as big as the previous problem. Previous problem we have a upper limit of 2 raised to 31, which is close to 2.1 trillion. All right, but this one, the ID, the upper limit of ID is only 10,000, and that won't take a long time. It's relatively a very small number for the computer to compute. All right, any question?
No.
Yes?
No.
Okay. All right, so that's the answer of this problem. And I am thinking that this one is a harder one. The size of the spreadsheet. I will provide, because we don't have a lot of time. It's already 3:49. I will provide you with the answer on the slides, and you guys can check the answer and then try to solve the problem. However, I think it will take longer. It will take longer than 10 minutes for me to explain about this. All right. Then let's try to do this one. This is a very famous story in the history of China. All right, and we don't know how many soldiers that Han Xin has brought with him. So Han Gaozu just tried to ask him, and Han Xin replied, if you divide the number of my soldiers by 3, you'll get 2. If you the remainder will be 2. If you divide it by 5, then the remainder will be 3. If you divide it by 7, and the remainder will be 2. So that's the only information provided by Han Xin. Han Gaozu wasn't able to figure out how many soldiers that Han Xin had brought with him, and so he asked this problem. He asked help from Zhang Liang for this problem, and Zhang Liang wasn't able to solve this problem either. And later on, there was a book. There was an answer provided by a book, and a very old book. I don't even know the name of it, and that's not a key point of this problem. But I will try to use the enumeration to solve this problem for you. All right. So we'll have like A1, B1 is equal to map int inputs dot splits. Alright? And then we'll copy and paste it for 3 times. And we'll get A2 and B2. A3 and A3 and B3. B2. Alright. And then we'll, because the M, the lower bound of M is 1, so we start with 1. We'll try every number. Starting from 1 until we find a number that meets the description of the problem, alright? So M will start from 1, while M divided by A1 is not equal to 0. M divided by A1 isn't 0. Isn't B1, I'm sorry, isn't B1. Or M divided by B2 and the remainder isn't A2 and the remainder isn't B2. Or M divided by A3 and the remainder isn't B3. Then we will increase M by 1. So we'll start with 1 and 2 and 3 and 4, etc. and try each number. See if it meets the statements made by Han-Xin. And if it meets all the criteria, then we'll exit this while loop. And that M is the answer to the problem. Alright? Is there any other way that it can solve this problem efficiently? Yes. Yes, there is. However, it would take a lot of the mathematics for you to understand. So I will skip it. This one is good enough for a upper bound of 2 times 10 raised to 6. That is 2 million. Okay? When the upper bound is 2 million, that was still fine. We can still do it in this way. Alright? Is there any problem? If you don't have any problem, that will be it for today. And next week we will start. I will show you how to use for. How to use for loop, and which will be a very, very useful tool to code in Python. Alright? And next week will be our last class meeting. And also my last class that is taught in English, because I won't be able to do it anymore later on. I'm so sad. Yes, I'm crying. And because you guys are the last year of this language gifted students, and I won't be able to teach the computer science in English anymore, and this will be the last chance of mine next week. Alright? Okay. Alright, this will be it for today, and I will provide you with the answer of this, the size of the spreadsheet, and you guys just go ahead and practice, and we will see you next week. Any question? If not, let's call it a day.